Okay, so what we're doing here is trying to figure out how the effect of baseline shifting affects our sine or cosine graph. You're looking right now at the parent functions, y equals sine of x right up here, and y equals cosine of x down below. Notice that again, sine starts at the baseline, rises up to the top, goes back to the baseline, down to the bottom, and back to the baseline, all in one cycle. So it starts at the baseline, up to the top, back to the baseline, down to the bottom, back to the baseline. Cosine starts at the top, goes down to the baseline, down to the bottom, back to the baseline, back to the top. Remember how sine and cosine are different. So down here we see some instructions that say the baseline of each of these functions is 0 because there is no plus anything out here after the function is over. Had there been something such as down here plus 3, that tells us that our baseline is no longer the x-axis. Our baseline has moved up 3. So that means if we wanted to graph y equals sine of x plus 3, we would have to go, instead of starting down here where the baseline is, you see in green the normal sine function, we will actually start up here. So it's important to draw your baseline as a dashed line wherever you are actually starting your function. So this is our new baseline. We ignore the old baseline. It is a sine graph, which means when we're at 0, we start on the baseline. When we get to pi over 2, we are up at the top. When we get to pi, we're back on the baseline. When we get to 3 pi over 2, down at the bottom, 2 pi, we are back on the baseline. Then it continues like that forever and ever and ever. Amen. So here's what our graph would look like if the baseline had been shifted up 3 spots. This is y equals sine of x plus 3. Again, that 3 has to be outside of the parentheses for it to be a baseline shift. Otherwise, it'll be a phase shift, which we'll talk about later. This one also has a phase shift. It's -2 outside the parentheses, which means we need to move our baseline. What do you think? That's right, you're brilliant. Move it down 2. So instead of the baseline being right here on the x-axis, it is now down here at -2. So we draw a dashed line that represents our baseline and finish drawing the cosine function. Y equals cosine of x minus 2. Remember that cosine starts up at the top. Well, the top is only 1 above the baseline, right? You see it in the green graph. The green graph was 1 above the x-axis, so our new cosine graph still needs to be 1 above the baseline. So it starts at the top. At pi over 2, it's on the baseline. At pi, it's at the bottom. 3 pi over 2, back to the baseline. And at 2 pi, back to the top of the cycle. So we're looking like this. Looks very similar to the green one. It's just been shifted down 2. The cycle continues again, starts at the top. At the first quarter, it's on the baseline. Halfway, it's at the bottom. Third quarter, back to the baseline. And the fourth quarter, back to the top. So that is how we deal with baseline shifting. Each of these down below will have a shift in their baseline. Try graphing them on your own. and see how you do.